We are going to talk about vectors. I've already briefly mentioned them in class, but we're going to delve into vectors in a little more detail now. So first of all, what is a vector? A vector is a quantity which has both magnitude and direction. So a vector has magnitude and direction. Okay, so for instance, let's say we're moving at, or some object is moving at 3 meters per second. This by itself is just a speed. So this quantity we can call speed. It tells us the rate of change of distance with respect to time. And we can make it a vector by doing something very simple and just adding a direction. So 3 meters per second, let's say east. Okay, so here's our direction. This is our magnitude, and together these represent a velocity. Okay, now what does this mean? Well, it means that we have a vector. A vector we represent, well, we graphically draw a vector with an arrow, like that. In fact, maybe before we draw that arrow, let's draw an axis. So we can draw the following. So let's say we had this coordinate system, and we can let the direction to the right be east. So upwards is north, and this velocity which we have has magnitude. Now the magnitude is represented by the length of a vector. So I know it's 3 meters, so I'm going to let each of these segments equal 1 meter per second. So we can draw this vector in the following way. It is an arrow which stretches out a distance of 3 meters per second on this coordinate system. Okay, now what's great about vectors is it doesn't matter where we start them. I could easily start this vector right here and move 3 units over there. Or I could draw it back here and move 3 units this way. All 3 of these vectors are the same thing. And to represent a vector, we have a special notation. So for this particular vector we've been talking about, we can call it V. And to indicate that it's a vector, we just draw a little arrow on top, like that. And now, dealing with this vector, although it's specified, we specify its magnitude and direction. If we want to do any operations with this, like addition or anything else, these 2 quantities are maybe not the best things to have. We want a better way of representing a vector, and the way we can do that is to write down how these vectors are moving in each of these directions. So here we have 2 perpendicular directions. We have east and north. The east could easily be x and north could be y, and what we really care about is how far this vector goes in each of these 2 perpendicular directions. So if you notice, in the east direction, this vector goes a distance of 3. And in the vertical direction, or north and south, we don't shift anywhere in that direction. So we can list that as 0. So we can represent this vector as an ordered pair of numbers. And vectors do have units, so we can include units of meters per second. Okay. Now, What about if a vector is shifted in more than just one direction? So let's pick another color here. And let's draw a vector. Let's say we have a vector which goes 2 in 2 units in the east direction, and something's going crazy here. Okay, so let's say we've gone 2 in the east and we've gone 3 in the north. There we go. So 1, 2, 3, 1, 2, and so our vector looks like this. There we go. So this vector, we have a component which goes in the east direction and a component which goes in the north direction. We can write this vector in the following way. Let's say this vector is A. So this is vector A. This vector A we can write as, in the east direction we have a distance of 2, and in the north direction we have a distance of 3. And again, this is all in meters per second. Now, if you specify a vector in this way, how do you find the magnitude of this vector? Well, the magnitude is just the length of this vector. And if you notice, this is a right triangle, this purple triangle here, and we can use Pythagoras' theorem to find the magnitude. And the way we write the magnitude, there's a couple of ways. You'll either see it written the vector with absolute value signs around it, or just the vector without the arrow on top. And using Pythagoras' theorem, it's 2 squared plus 3 squared, which is the square root of 13. And we'll get meters per second. And you can go ahead and compute that square root. It's like 3 point something or other. Great. Now this is how we deal with vectors. If you're given both components, then you know magnitude and you can find direction. It's sufficient to represent a vector like this. You don't have to specify a direction like this. Knowing these two components is enough. And just a little bit more notation in general for a given vector. Let's say we have a vector b. We represent its x component with a b subscript x, and the y component with b subscript y. So on axes, we can write this as, if this is our vector b, then this length is by, and this length is bx.